All right, so the activity series of metals helps you predict whether a metal will replace some metal ion in a compound. Okay? That's what it's used for. Now we also have a series of halogens down here, and this also will predict when you can replace a halogen in a compound. So the ion part is where it replaces something in a compound. So these are the parts that are in a compound. These are the metals that are by themselves. So if we look up here in this combination here on this worksheet, I have a zinc, and I want to put it in a solution with silver nitrate. And the question is, do I have something happen or not? Well, the way we figure that out is if zinc is above silver, okay, look at where they are. If zinc is above silver, zinc is more active, okay, and it will displace silver. If zinc is higher than silver, it's more active and it will displace silver in a compound. Okay? So the way you use the activity series is you look at the part of the compound that's by itself, and that's going to be in this first column here. And then you look at the compound and see if there's something like it in terms of a metal replacing a metal, something like it that you can find in this column. If the part that's by itself is higher than the part in the compound that it's like, then it will most likely displace that metal. Okay? So if I have zinc and I put it in a solution with silver nitrate, zinc, because it's higher on the activity series, actually it's more active, and that's why we put it higher. I'm sort of explaining it backwards. Zinc is more active and we put it higher than silver. Zinc is going to go over here and it's going to kick out that silver. So on the other side of the equation then, we're going to have silver by itself. Alright? And that's because zinc is more active. That's why we list it higher on the activity series, and it will replace the silver. So then the zinc then is going to join up with the nitrate. Okay? It's going to kick out the silver and join up with the nitrate. So we need to write a balanced formula where zinc and nitrate are joined together. Okay? Now, in the last unit, we learned to write balanced compounds. So if I'm going to put zinc and nitrate together into a balanced compound, what do I need to do? How do I figure out how to balance that compound? What? That's where you're balancing a whole equation. We want to balance the formulas first. Okay? What did we do in the last unit to balance a formula? Use there's two different kinds of charts we're going to use in this case. Okay? What do I have to do to get it to be balanced if I'm putting together this kind of ion and that kind of ion? Negative and positive. So what negative charge or positive charge do I put on a zinc? Where do you find that? The periodic table with oxidation numbers. There's a 2 plus on the zinc. Okay? How about the other part of this? Where do I find that? The polyatomic ions list or the common ions list. Okay? So what charge do I put on it? A negative. Okay? So this is where I'm putting together the formula. Okay? And to figure out how the formula should be put together over here, I need to know how many zincs and how many nitrates to put together. To do that, I got to figure out the charges. So here I'm figuring out charges. I've got a 2 plus, I've got a 1 negative, and what I want to know is what coefficients can I put in front of those to get a 0, because I want my compound to be neutral, to have no charge when I'm done. So what numbers do I put here to make a 0?
1 and 2.
1 and a 2. So that means I need 1 of these and I need 2 of these. Okay? So to put together the compound, how do I show that I've got two nitrates bonded with this zinc? Parentheses and a subscript 2. That's how you figure out the balanced formula. So here we're going to do the same thing. That's what's going to go there. Okay? Well, I will, but I haven't told you how you know that yet. Okay, there is a way to figure that out. We'll figure that out a little bit later. All right? All right. So there is a replacement, and that's the result we get. All right, so this does happen. Now on this worksheet, you don't have to go through all of the balance in the compound just to predict something's going to happen. All you have to know is zinc is more active than silver, and so you will get a reaction. Okay? Yes? Mm-hmm. If the metal that's by itself is higher than the metal in the compound, it will replace or displace the metal in the compound. Okay? The metal by itself in the equation is higher than the metal in the compound, then you would assume that it's going to replace the metal in the compound or displace the metal in the compound. So the reaction occurs then because the explanation is that zinc is more active than silver and will displace it. Okay? So we're at the point now where we're predicting the products of a reaction. Okay? When we finish this unit, you'll be able to predict whether reactions will occur or not. Okay? So that's what this worksheet is all about. You have to figure out if it will happen or not. Okay, now,
so each one to go back to zinc, right?
For this set right here, all these are about zinc replacing something else like it in this column here.
The next one will be about zinc too, and then one after that will be about zinc.
Huh?
All of them will be about zinc.
Well, we go down a little bit, then you got silver. And then you got copper, and you go to the back, and you got magnesium.
Yeah.
Okay? All right. Let's do the next one then. Why don't you do the next one here, zinc and reacting with copper nitrate. See how you do. Okay, and then I'll come back behind you. This is your chance to quiz yourself and see how well you've understood what I've talked about so far. And then I'll show you one more, and then I'll turn you loose a little bit to work on it just a little bit in class, and you'll finish it at home. Okay?